Greetings, ladies and gentlemen, as well as fellow learners. Welcome back to our series of videos on number patterns. Just to quickly introduce myself, I am Mohamed Elias Masubana, as you can all see on the presentation slide. And to give you a background about myself, I am responsible for the design, development, and implementation of the learning material, amongst other things. I think that's very much important to highlight. And in today's video, we are going to continue from where we ended in our previous lesson, which was on arithmetic patterns. In our previous lesson, we looked at arithmetic patterns and determining their respective mean. And in today's lesson, we will be looking at quadratic patterns and sequences. It is also important to indicate that this tutorial lesson is intended mainly for learners who are in grade 11 and 12 the objective with the objective of instilling confidence through first explaining the most fundamental, or these are the most basic concepts, and going through tutorial problems with you. Lastly, please tell us which syllabus, if there's any, you are taking at school, and if the topics covered on this presentation slides are relevant to it, because we'll highly appreciate your feedback, and that will also help us in preparing the material. Just to continue with our slides, here we are looking at the disclaimers, and I'm quickly going to run through the disclaimers, which reads as follows: that this presentation slide is a property of the center, and it cannot be reproduced or shared by anyone. Anyone who seeks to obtain a copy, be it an electronic or hard copy, must send a request and be granted permission to do so. Secondly, this document, it is for educational purposes only, and it is intended mainly to assist you in planning and as a guide for your cycle tests and examination. The development, implementation, and timing of any topic or feature in this document remains at the sole discretion of Digital X, specifically the center. And lastly, the center or instructor will not be held responsible for any learner failures. I think that's the most important point that needs to be highlighted. Learners are expected to take their schoolwork seriously. And just to give you an overview of today's lesson, here are the learning / specific outcomes, which goes as follows: that upon completion, learners should be able to do the following: should be able to differentiate between an arithmetic, quadratic, and in today's video we'll be focusing mainly or specifically on quadratic sequences and patterns. So it is to differentiate between arithmetic, quadratic, and geometric sequence, to calculate the value of any term in a quadratic sequence. Thirdly, to determine the number of terms in a finite quadratic sequence. And lastly, to analyze any problem and identify suitable strategy to solve it, including using a combination of processes where appropriate. And lastly, this is just a prerequisite, which goes as follows: that prior knowledge from previous grades or classes will be to your advantage. So let's look at this one over here, and it's just a general definition of a sequence. But we will, in our next slide, we will look at a more specific definition of a quadratic sequence. And a sequence can just be thought of as a list of numbers written in a definite order, and the order it is as follows: a subscript 1, which represents the first term of the sequence, and a subscript 2, which is the second term, and a subscript 3, which is the third term of the sequence, with a subscript n being the nth term or the last term of our sequence. And there are different notations that are being used to represent a sequence. One of them, the most common one, it is this one, and that's what we are going to stick with on the. Now, in the previous presentation slide, we looked at a more general definition of a finite sequence. However, in this slide and the remaining part of the lesson, we will be looking at a quadratic sequence and its definition, which states that, and I'm just going to read through it, which states that a quadratic sequence is a sequence in which there is a constant second difference between consecutive terms. Now, we'll illustrate this using examples in the next slides. And I have to indicate that to find the value of a, which is determined slightly different from an arithmetic sequence. And please, if you have not watched the video on arithmetic sequence, I'll strongly encourage you to go and watch it. Now, to find the value of a, which is determined slightly different from an arithmetic sequence, and I'll just do a quick recap on how we determine the value of a for an arithmetic sequence. We recall that from the given formula for determining or to determine the nth term of an arithmetic sequence, it is given by the following formula: t subscript n being the position of the term, it is equal to a into a plus into n, which subtracts 1, and all of this it's multiplied by a constant difference d. So when we substitute the following here, when we substitute 1, which is the position, we ultimately end up with a. So I'm just going to do this by doing the following. So when you multiply this gives you 0. When you multiply this, then what you end up with it's 0. So obviously the value of a will be equal to the first term. The value of a will be equal to the first term of the sequence. And like I said, with a quadratic sequence, the story is a bit different. To find a, I'll show you how we determine the value of a. But what I want us to do is to focus on this particular diagram over here. So if you look at this first column, each entry here is determined simply by substituting here the value of n into the formula. So when you do that, you see that t subscript 1, or the first term, it gives you this. The same goes for the second term. If you substitute 2 into the formula, what we end up with this. The same applies for t, the third term, the fourth term, so on and so forth. So on the second column, which is this column here, I've just subtracted each successive term from the previous one. So simply meaning that I have subtracted this from that. The same applies, I've subtracted this from that. And what we end up with, just a sec. So if we subtract this from that, so what we are going to get, we are simply going to get 2a. The same goes for this. So when we subtract this from that, when we subtract this from that, what we have, we also get 2a. Now just to recap on what I was saying. So I said if you subtract this from that, what we get is 2a. The same applies for this. If you subtract this from that, we also get 2a. Now we're going to take this 2a equated to d. So when you take 2a and equate it to d, which is the second constant difference, when you equate it 2a to that and divide on both sides by 2, what we end up with, it is a, which is equal to d, which is divided by 2. I hope you all follow. Now just to do a quick recap. Now for us to find the value of a for a quadratic sequence, I have shown you by using this particular diagram here that we subtracted each successive term from the previous one, and when we subtract each successive term from the previous one, what we get is that. The same applies if we subtract this from that, what we get, it is that. And the same applies if we subtract this from that, what we end up with that. So for us to get 2a, we're just going to do the exact same thing which we did with this, the entries on this side. So we're just going to subtract this from that and subtract this from that to get 2a. And everything else is history. We equate 2a to d and divide on both sides by 2 to get a. So that's how we determine the value of a. So it is important to know that both arithmetic and geometric sequence or patterns have similarities in determining the value of a. So just stay tuned for our next video, as I will be explaining and comparing the similarities between the two, between an arithmetic and a geometric sequence. So I have illustrated everything. I have shown you how we find the value of a for a quadratic sequence. Okay, so let's look at this example. And here we are requested to determine the nth term, or rather the general expression, as well as the 30th term of the given sequence. And since, well, we all know that we are dealing here with quadratic patterns or sequence, the sequence, it is as follows. We have 7 being the first term, 13 the second term, and 23. So in this sequence we are only given 4 terms. So as mentioned, we are requested to determine firstly the general term as well as the 30th term of the sequence, the value of the 30th term of the sequence. And as mentioned, for us to find the general term, what we are going to do, or we are going to look for both the first and the second constant difference. So everything is written down here. Everything is written down here. As we can all see, I wrote the first difference, it is 6, and the second difference, a constant difference of 4. So I'm just going to rewrite everything down for the sake of making things much easier to understand. So here we have 6. So we have 6 here. Excuse my pen. And we have again here. And mind you, this is the first difference. So we have 10. When you subtract 13 from 23, what you get here, it is 10. And when you subtract 23 from 37, what you get, it is 14. So this becomes our first difference, and obviously our second difference here will be 4. The same goes for that. When you subtract 10 from 14, what you get is 4. But like I said, that in order for us to determine the value of a, what we are going to do is just to take 2a. It is to take 2a and equate it to 4 to get the value of a, which is 2. Now let's move on to find the general term of this particular sequence, which is given by the following. So to determine the general term, recall that the formula for determining the general term of a quadratic sequence is given by the following formula: t subscript n a squared plus b n being the position of our terms, and lastly a constant, some constant c. So already we know that the value of a, it is 2. So what we are going to do is just to do the following basic substitution. We are looking at t subscript 1, or the first term of our sequence. Then we just do basic substitutions. So from there we have that. So I'm going to write everything down. I hope you all can follow. So we have b plus lastly some constant c, which is what we are going to look for. And mind you, we all know that the value of tn, the first term, it is 7. It is 7. Okay, so this will give us that. So I just want to show you how we actually got this. So just to show you how we ended up with being equals to 0. So I'm just going to write everything down. So from there we have b plus c. So when you transpose everything here, you subtract 2 from 7, what you have, it is 5. Okay, so let's go again for term 2. So term 2, what we have here, we have 2. So I'm going to write everything down quickly. Plus 2b plus c, and this should give you, so this is the second term. So obviously we're going to consider the term of our expression, the term of our sequence, which in this case it is 13. So if you write this down, what we have, this gives us 2b. After doing basic transposition, so we have 2bc, which is equal to, when you transpose, so this is 4, it is 8. So when you subtract 8 from that, it gives you 5. It gives you 5. So this takes us back here. So when you take this, so let's call this the first equation, and this will obviously be the second equation. So when you subtract either, so depending on how you start, so you can just subtract equation 1 from 2, and what you should get is this. I hope this makes perfect sense, ladies and gentlemen. And if there's anything that you do not understand, let us know. So now let's move to the next slide. Here we are going to determine the value of c. So to determine the value of c, what we are going to do, we have the value of a, we're going to substitute it. We have the value of b, we are also going to substitute it back to any of the two equations that we have formulated, either equation 1 or equation 2. The choice is yours, it doesn't matter. So ultimately we have the value of c being equal to 5. So the general expression, or the general term for our sequence, it is t subscript n, and it's given by 2, which multiplies n squared plus 5. And lastly, we are requested to determine the 30th term of the sequence. So I've worked this thing out, and what we have as the 30th term, it is 1805. So just go through this on your own and see if you do understand. I'll see you on the next slide. So I want us to look at the next example on quadratic number patterns. Here we are given the following pattern, number pattern 4 being the first term, P, second term, 11, Q, 22. And we are being told that it has a constant difference of 1. And 2.1 says we must show that the value of P is 7 and the value of Q is 16. And secondly, 2.2 says we should determine the general term n, Tn of the quadratic pattern. And 2.3 says also we should determine the value of n if t subscript n is equal to, so we're going to look for the position here, it is equal to 232. And lastly, we must find the sum of two consecutive terms if the pattern is 1227. We are requested to calculate the difference between these two terms. Now let's move to the next slide. And here I'm just going to do basic, or rather to look for both the first and the second difference. And to look for the first difference, we obviously know that we are going to subtract 4 from P. Then we subtract P from that, and we already have that. If we subtract 4 from P, we get that. That will be our first difference. And if we subtract P from 11, we get that. The same goes for subtracting 11 from Q, we get that. This gives us our first difference. And to find the second difference, we are going to do the exact same thing. We're going to subtract P minus 4. We're going to subtract it from 11 minus P. And what we get is that. But keep in mind, we are told that they all have a first difference. They have a constant difference of 1. So we're going to equate this to determine the value of P. And to do that, we just going to do basic, we're going to work this out. And ultimately we have that. So when you work this out, you just equate this to 1, which is what we did over here. And you do the exact same thing with determining the value of Q. You also equate it to 1. So that's how you find the value of P, and that's how you find the value of Q. I hope this is straightforward and we all understand. Now, now the next question says you should determine the general term, or rather the nth term of the quadratic pattern. But before that, let me quickly rewrite the quadratic sequence, or the terms of our sequence, and they are as follows. So we have 4, we have 7, 11, 16, and lastly 22. So these are the terms of our sequence, and we are told that it has a constant second difference of 1. So if you subtract 4 from that, so I'm just going to rewrite everything down. So if you subtract 4 from 7, what you get, obviously it becomes 3. The same goes for that. You get here 4, so you get 4. And when you subtract this from that, you get here 5. And when you subtract that from that, what you get, it is 6. And they all have a constant second difference of 1. So we are told this already. So they have a constant second difference of 1. So to find the value of A, we're just going to use our formula, which is 2A, and we equate it to 1, and the A value of A becomes half. So it just becomes half. And substitute everything to find the general term. We're going to take our formula, and substitute everything back into our formula. So our formula for determining the nth term of the sequence of a quadratic sequence is given by this, is given by that, and c being the constant number. So we're just going to substitute everything into the formula, and we have this over here. So after working out everything, we're going to get that, and we're going to do the exact same thing with the second term of our sequence, and that's what we get. So let's look at the next slide. And in our next slide, we have determined the second equation. So we have both first and second equation, and you can just subtract equation 1 from equation 2, and after doing that, you get the value of b being equal to 3 over 2, and you can just take the value of b and substitute it back into the first equation, and obviously you get the value of c being 2. And going back to our formula, we substitute everything, and the general term is determined by the following equation, or rather the following formula. That's how we get the general. Now, just to reiterate over what I said in the previous slide, I mentioned that the general or nth term of this particular sequence or pattern, it is determined by the following rule. So I'm just quickly going to rewrite it. So that nth term of the sequence is determined by the following rule: 1 over 2 n squared plus n plus a constant 2. And please keep in mind that n it is greater than 0. So after getting the general rule, we are going to equate it to 232. So you're just going to equate it to 232, then transpose it to the left hand side of the rule, so that we can be able to factorize this. So the value of n will obviously be 20. So the position, or the 20th position of our sequence, will have the value of 232. Please go through this example on your own to see that you do understand. Now, to wrap up our example on quadratic patterns, I want us to look at this last question. And in this question, we have been told that the sum of two consecutive terms in the pattern, it is 1227, and we are being requested to calculate the difference between these two terms, which we do not know their values. So I'm quickly going to write the following down. So we have t subscript n plus 1, t subscript n, which subtracts tn. This is what we are looking for. I've went through the solution here. What I'm going to do is just to explain everything quickly. But what I want you to also do is to keep in mind that the initial number of terms, they are actually 4 or 5 in total. So let me write them down. So we have 4, we have 7, we have 11, we have 16, and lastly we have 22. And I'm going to extend them with 2 more additional unknown terms. 2 more additional unknown terms, being Tn as well as Tn plus 1. And for the purpose of this, I've went with Tn and Tn plus 1, okay, because these are the only two terms which, when added together, n becomes a natural number and it is greater than 0. So n becomes a natural number and it is greater than 0, as indicated with this particular notation here. So we are going to consider this and that. So as I have shown here, that we're going to add t subscript n plus 1 to tn and equate it to that. So we're just going to substitute everything into our general rule, substitute n plus 1 into our general rule, and expand everything. So we've just expanded this, and ultimately we have this over here. So you're going to transpose, and you end up with n squared plus 4n minus 1221, and equate this in order for us to be able to factorize. Now we're only interested in the value of n which is greater than 0, and n being greater, then we go with n being equal to 33. So we know that t at 33, it is 596, and t at 34, it is 600. So when you add 596 to 631, it should give you 1200. But what we are requested to do is to calculate the difference. What we are requested here to do, it is to calculate the difference between t subscript n plus 1 and t subscript n. And I'm just going to subtract 596 from 631. So we're going to subtract 596 from 631, and you should end up with 35. Now I hope you do follow and understand everything. Please try to go through this particular example on your own, and if there's anything that you do not understand, just reach out by sending us an email. So let's go. We have finally made it to the end of our presentation slide, ladies and gentlemen and fellow learners. Just to do a quick recap, here's what we covered in today's presentation. We looked at the definition of a quadratic sequence. We determined the value of the kth or general term of the sequence. And lastly, we looked at the number of terms of the sequence. And please do not forget to provide us with feedback by filling in the form and your suggestions on what can be improved. Thank you for watching. Until next time.